Alright, I think, okay, the mic's being picked up. Alright. We're live. Bing chillin'. With all 0 of you. Started a bit early today. Oh, man, I don't even know where to start with this. I really don't know where to start with this. I have to write documentation. Let's go to my README. Okay, I do have to enable the collate function. This is a pretty important functionality. This is one of these things where, like, I'm just kind of scared to do it. I don't want to do it. And so I build up this thing in my head where I'm like, oh man, I don't want to do it. It's probably really difficult. And then I do it, and then it's not that hard. So I guess, yeah, I'll probably spend today working on this, because I can't train anything without this. So this is kind of a bit of a blocking issue. Downloaders are really important. This is mel spec augmentations is whatever. I do need to enable evaluation as well. So that is something I'll work on when I'm working in the training. That's probably when I'll work on it. All right, and then I do have to write documentation, a lot of documentation, but I don't write documentation unless someone asks a question, because if there are no questions, then you can understand the code. Done. So forget I will not worry about documentation. Sucks to suck. So if you have questions, do not come to my account, but rather come to this repository and make an issue. Then I'll make documentation. I'll solve your issue, and then I'll make documentation, because if you have a question, then other people probably do as well. So with this in mind, let's try. I mean, I'm a few minutes early. I should have started in 3 minutes, but that's whatever. So how's all 0 of you doing? Good? Good? That's great. Awesome. Let's see. So if I work on the collate, I already have the collate function defined here. And then I feed in the data loader as a parameter, and then whatever transformations, which I do here. And then we will pad. So this is, let me make a note here. This is dynamic padding to fit to the longest segment in batch. Okay, so we don't do offline padding because that's really expensive, and that's actually really annoying to deal with. This paradigm that I'm taking from here, that you see right here, this is taken exactly from automatic speech recognition, ASR systems. The goal is that with ASR systems, you were just simply framing the audio and making predictions as to which phoneme is in each frame, right? Actually, if I draw this out, this might be a bit easier to understand. And this will be actually quite important for later work. Pretty much this will inform the ASR paradigm, really informs what I'm doing here, because really the whole, what is happening here, man? All right, the whole paradigm that I'm trying to build out here, and the underlying hypothesis that automatic speech recognition system or automatic speech recognition type training is sufficient for detecting deepfakes. This is the underlying hypothesis that I'm building out to test and see if this works. So, okay, so we have, let's go back to our classic audio file. And, you know, maybe we convert it to a MEL spectrogram. So it kind of looks like this. Whoa, cool. This is totally what spectrograms look like, okay? And I can even pull up MEL spectrogram. Images. So you can see this is kind of what a MEL spectrogram looks like. I can't drag it in here. That sucks. So you have something like this, and the idea is that, so this is over time every 5 seconds, right? So let's say this was milliseconds. All right, this way I could just kind of get my point across here. Let's say this was every 5 milliseconds. Well, phonemes, let's look up the average duration of phoneme is between 74 to 181 milliseconds. Oh wait, this is in Polish. We are not Balkan posting today. Does it even say? Okay, I'll take this. It's about 50 milliseconds. Okay, so if the average duration of a phoneme, which is b, k, right, like the core sounds that make up the language we speak, it's very likely, obviously this is 40 seconds, but let's say it's 40 milliseconds. This frame that we're seeing probably makes up one phoneme. And the goal of ASR, let's say this is 2 seconds. The goal is to take each frame of, let's say 50 milliseconds, all the way to the last 50 milliseconds, and then run a classification system in which we have, we'll have 30 labels, right? So we'll have, let's say, 26 letters, a blank, maybe punctuation, period, comma, exclamation. I don't know what else. I know that in ASR training, it won't just be the set of letters. I know it'll be the set of letters, blank, and then other additional things. So let's just say it's punctuation. And then what we're doing is on a frame-by-frame basis, we're saying, I think we're trying to get the network to learn, I think this 50 millisecond frame is, this label, let's say label 7, which then maps to, F or whatever. And then this still may be 7 because maybe our prediction frame is smaller than the entire phoneme. So maybe this might still be F, and then this frame is U, and then this frame is still U, and then we keep going until we have C, K, K, and then Y, and then all of a sudden, we have suddenly trained a network to say, fuck you. And lo and behold, we have an ASR system. So at its core, what we're doing is training a network to make a prediction on each frame, and each frame will be then classified to a phoneme. Now, why I'm doing this? No. Now, the reason why I outline this is because this core idea is what I'm trying to build out for deepfake detection. Now, instead of having, let's say, a classification set of 30, I want to reduce it down to 2, real and fake. And so now, let's say we're using a convolutional-based system. The features that are being learned to discern between the features of each phoneme, we no longer need that compute and the direction of learning, so to speak, to go in the direction of being able to discern between phonemes. What we want is that those convolutions, maybe if there's an RNN, maybe if we're using attention, maybe if it's like whisper, for example, we want that learning mechanism to shift away from discerning between phonemes to discerning between the characteristics of, generally speaking, any phoneme. So if we have, the classic F here, what is happening, brother? If we have F here and we have another F here, but for some reason a bad actor stitched together, and this is a fake F, we should be able to discern between the real and the fake F, the real and the fake A, the real and fake any letter, any word, any sound, ideally. So this is why I'm heavily pulling from ASR when it comes to this pattern transform collate function, and this is why we're doing the dynamic padding. We shouldn't care about what the length of the audio file is that we want to run prediction on. Same with ASR. We'll just pad it dynamically to the longest in the batch. And, we'll run the necessary transforms. That's no problem. And then we'll have the batch, and then we can train. We can do the training and see how it goes. And I think this is sufficient to work. As you can see, I do have checkpoints here. I did an end-to-end ASR style with a cross-entropy loss. This was Deep Speech 2. I pulled this from Assembly AI. Why is my thing over here? Assembly AI train ASR. They have, yes, I believe it was this one in which they kind of give, no, this wasn't it. No, this wasn't it either. They have one where we build they build Deep Speech 2. And so I use this. This is the checkpoint here, and you'll even see the models. Where's audio, not data, audio sleuth, trainer. Oh, detection mod. Oh, yeah. So these are, I already have the reference here. I made marginal naming changes in documentation. This was just for my own. That way I made sure I understood the code that I was implementing. But at its core, I already tested out Deep Speech 2 in a very haphazard way, not really fitting within this package. And it did show promise. And so now really what I'm trying to do is just make the whole thing work as a comprehensive Python package, and then maybe build an even more complicated system with more data, maybe fancier optimization tricks for faster inference, maybe even seeing how much performance we can squeeze out of a smaller model. This is a convolutional based plus RNN style training. So by today's paradigm, this is quite small. We're not using multi-head attention and all this fancy stuff. So, maybe we can use Hugging Face just released Hugging Face Distill Whisper. The absolute brilliant researchers over at Hugging Face made a distill, like a student model version of Whisper, and they were able to get a similar word error rate, 51% fewer parameters, 5.8 times faster, while performing within 1% word error rate on out of distribution test data in a zero-shot transfer setting. So we have a arguably smaller version of Whisper that we could also train as well, compare it to Deep Speech 2. I think that wherever ASR goes, we can just kind of take these networks and plug it into this paradigm of training, and we could actually get something quite meaningful. Okay. So this is where we're at. This is what I think is, this is my hypothesis, and I'm building all of this. Discard. I'm building all of this just to even see. Whoa, what? I've never done this before in VS Code. What is this? Huh? Okay. But yes, I'm building all of this just to test this hypothesis, which could fail completely, and it could not be the case, right? But this is just how this shit goes. So, let's just go. I need to, let's work on the collate function. And then we can just go from there. So I have over here, let's make this full screen. I might change the music here. I do love this album. It's a great album, but I might play Love for Rent. I love this album just as much. All right, cool. So far, so good. So let's begin. We have the pattern transform collate. This was also taken from, let me go back to the detection modules. Yank, and then yeah, this was also implemented from the same blog post where I got the deep speech implementation from. So this should be no problem. Let's add args. Data loader of torch data set. Transform module. Any designed notations from audio sleuth dot augmentations.com. And then this will return processed audio. This will be a tensor. Oh yeah, this says tensor list by list. However, it's just 2 tensors. I forgot to make that. All right. Tensor representing, this should be batch size. I forgot if it was feature size. We'll do this in the debugger as well. Feature size, num frames, I believe. And then final labels. This is also a tensor. Num frames represents the number of frames from the longest audio file in batch, because we dynamic pad. Final binary labels of final encoded. I'll just say encoded labels of size. This would be batch size. Is it num frames? It should be num frames. Because we're gonna be doing frame-wise prediction here. And so we should have, for each batch, we should have a number of predictions for each frame. But I'll need to debug this to verify. I don't fully remember what this yields. Should I do, I should probably do typing at some point. Module isn't defined here, that's no problem. I'll remove that. All right, so the design of this is that it is fed the data loader, the transform, which means that in our trainer now we should probably be making some changes here. So I have the model, the loss, the optimizer, the data loader. Should I need to add the collate function here. When's the transform defined? Hold on. what did I do here? If I have the transforms, the data set, the data loader, wait, but can't, hold on, let's see. Data loader, collate. Yeah, let me see. Oh, it is fed into the data loader itself. So then, okay, then let me rework this so that way it fits in the data loader, and then we should be good to go. This should be pretty easy. And so the question is, if we define it within, let's see. Because when we put it in the data loader itself, we'll essentially need to do a lambda to map the collate function all the way across all the files in the data loader. So we will need to debug that as well. Core train function, begin training. This is very trivial. And so the trainer is the data loader, which should have the, so then, all right, here's what I'm going to do. Let's go to new file. Actually, I'll make a new folder. New folder, examples. And then I will make a new file, example, or train example.py. Import audio sleuth dot from audio sleuth dot trainer import trainer. This way we have the dummy, the most simple example, and then this will help with debugging as well. Sure, I'll just take this. This is quite arbitrary. Huh? Why didn't you take all this? Yeah, that should work now. From import audio sleuth dot augmentation. Actually, hold on. From import. There we go. And then from audio sleuth dot data dot data sets import half truth. Let's say path to txt equals what, I still have it, half truth. It's the train file, yeah, the train label here, and then I'm gonna have a downloader so that way anyone can just get this, although it will take quite some time to download. I think this is about, if I recall correctly, half truth was like, both of these should be around like 20 gigs, both half truth and wave fake. So let me just, all right, and then, yeah, I guess. What's going on? Python file. I'm in the audio sleuth. Okay, that's cool. Yeah, sick, bro. All right, let me new file. Alright. Do I need to, alright, import sys.path.append, insert. That should work. I don't like that, but it should work. Sick. What's up? Got the star emoji in the chat. Let's go. I am fabulous. Alright. Have internal module load load module in parent folder Python. Sure, that makes sense. I also have, yes, from 1, 2, 3 without the sys path, init, simulations, life. What? Dude, I always get so... confused when it comes to these. Start a sys.path.append. Wrap the code into one folder, create. So then, does each one have a Py project? Is this the my project API examples? Yeah. I would call blank the root folder. Function from API. No module, yeah. So using ... attempted relative, yes, I've also seen this problem. Py project. Alright, let's try this. But if I make a... I'm already in the... Okay, what... Do I not have a Py project already? I have a setup.py. Alright, let me try. Py project.toml. Let me just copy this. Sleuth. I don't care what deepfake detection. I'll deal with this later. Build system. Build backend. In this case, it's previously people used the setup.py file. Bro, that's what I have. Virtual. No, I'll just use this as path hack. Fuck it. Init. Alright. Oh, wait. Because if I go up, then no module name augmentations. Hold up. Sys.path. Import sys.path. Examples. Sys.path.append. Sys.path. Import augmentations. Really? Why not? Import augmentations. Let's try that. Bruh. I hate this, I hate relative imports so much, bro. Where's the example? Okay, that's fine, that's fine, that's fine, that's fine. All right. From sys. Or no, I'll just import. Because I put it in here. Yeah, I don't want this. Sys.path dot insert. And I'll go up 2 so that way I can just load in. Ah, fuck it. I'll just do this. Alright. Bro, what do you mean? If I go up 1, then augmentation should be here. Sys.path. What's sys.path right now? Yeah. Import audio. Can I import audio, Sleuth? Oh, that works. Alright, sick. Let's go. Is this augmentations? Augmentation. Bro, am I? Hold on. Import audio. Sleuth. Yo, sleuth dot augmentations. It does not. Audio sleuth dot data. Nothing is. What? Alright, I'll take it outside of audio sleuth then. We don't need the examples. Which means that this should be able to call this immediately. Examples. Yeah, I'm gonna train examples. Alright, cool. Bro, what do you mean? This has an init. So then, no module found. Oh my god. Sys.path. Import sys. Oh my god. Import sys. Sys.path. I'm in examples. But if I have. Let's close these. Have one module called another Python. But what is this? Can you just tell me how to... Oh my god, bro. Yeah, but how do I connect? How to integrate 2 modules? Dude. Typical me. Alright. Alright, towards data science, teach me something. Yes. All. Oh, where's my phone going off? Alright. No, but I don't want the function. I want the whole module. Have one directory, call another in Python. No, I want to import, bro. I'm not searching for this correctly, because I feel like this should be... What am I looking for wrong? Well, like, what's incorrect here? Calling. Dude, what am I doing wrong? All right. The init is here. This has an init. That's fine. Because within here, I could call data losses. This is whatever. I can call... Alright, I hope this works. Bruh. No module named audio sleuth dot augmentations. Sick, dude. I love being stuck on one thing for fucking 30 minutes. Import from parent directory. Please just tell me how to do this. This is the path. Alright. Append. Will this work? Data sets. What do you mean utils? It's right here, bro. Alright, then I'll just move utils and data sets. Alright. Yeah. Do I have OS? Okay. Then what I can do is just helper functions, data sets, and then I'll just move this here. Save, and I'll even remove this. Delete. Do you want to delete? Yeah. All right. Please just work. Oh, it did work. All right, cool. Easy, bro. I was not struggling for 30 minutes right now. Okay, so let me print debug here and then set the breakpoint down here. That way I can load everything. Okay. So now, data set. If I index this, one, yeah, this will return, as we can see, the file itself, and then the labels, the binary labels. So now I need to create a collate function, or I need to make this collate function friendly to the data loader. So let's instantiate a data loader. Data loader. loader. Let's see, from torch.data or utils.data, import data loader. And so now we have the data set. Batch size, let's say, is 32. Shuffle, yes, we do want to shuffle it. Sampler is the sampler. And then here we have the collate function, as you can see right here. Collate function, which I will say, oh, okay, this is interesting. Well, hold on. Does if we go to the torch data sets, when do they put in the transforms? So the transform is in the data set itself. So then I should enable the data set, or I should enable the transformations. And then, nah, it'll be easier to do the transformations in the collate. Pad and transform collate. And then this is from audio sleuth.data.collate import and transform collate. Now obviously this is going to get butchered real quick because this is expecting a data loader. Let me see. Collate. Really? What? There's no way they don't have a collate. They didn't define a collate? PyTorch collate. Receives a list of your get item. Okay, here we go. Basically, the collate function receives a list of tuples. If your get item function from a data set returns a tuple, which ours does, as we see. When we index our data set, it returns a tuple of the audio file and the labels. Cool beans. The main objective is to create your batch without spending too much time implementing it manually. Try to see it as a glue. You specify the way of stick together examples in a batch. If you don't use it, PyTorch only puts batch size. So then, okay, cool. So then what I will do, data is tuple. Data tuple. Input, output pairs from indexing our data set. And then here for audio labels and data, because oh wait, no, that this would be an individual, so this we don't even need to do a loop. Okay, this is nice. Nice-oo. But let me think about this. All right, let's see. Because if we do it like this in the data loader, then we do it per batch, and we're able to dynamically pad per batch. Ooh, I might like that more. Because if we do it individually, then the padding becomes redundant. Design choices, bro. Design choices. All right, so then, size. Design choices. All right, then yeah, I'll just keep it as a data loader. Suck it, bro. Sucks to suck. Data loader, and then I guess in the trainer we have the model loss optimizer data loader. pad of data loader transform processed audio final labels. But then if we feed in the data loader, then here's what I'll do here. Okay, let's go to the trainer. So this is fine. Let's see. Where's the trainer? And then I'll add the collate function here. What is the Python type for function? How can I specify the function type? Oh, it's callable. All right, cool. From typing import callable. And then after the data loader, we will say collate callable. Easy, bro. And then underneath data loader, self.collate function equals collate function. And then core trainer class. So then I'll need to, again, this is why you need documentation, not only for yourself, for other people. I'm going to need to specify to people, hey, build whatever collate function you want, but it's got to take in a data loader just because of life and society. So let's see. For this in self.dataloader, we got the audio labels. All right, so we'll figure out when to call this. So we'll need to start a training pretty soon. Self.collate function. All right, we're getting somewhere. All right, we're getting somewhere. Let me commit a few things. That way I can clean everything up. And then just get a dummy training going. All right, so git add audio sleuth. What changes did I make to augmentations? Oh, this is whatever. I can data. All right, so git diff audio sleuth data collate. What I do here, documentate. This is mainly documentation. All right, so status add audio sleuth data utils because we moved that, and then we moved that to data sets, I believe. Git diff audio sleuth data sets, and then we removed the transform. Yeah, and then we moved the transform. Okay, cool. Git status, git add audio sleuth data sets. Documentation and reorg. Git push. All right, so we have a few more things cleaned up. I'll git checkout audio sleuth augmentations. Like I made this, but like I don't need to worry about augmentations right now, so I'll just check this out. Okay. Again, as long as we're cleaning stuff up, we are doing fine. So then let's just get a model going. Let's just get a training going. Texture models. Did I have configs anywhere? Let me see, trainer. All right. Model equals. Let's go up from audio sleuth dot detection model import deep speech 2, and then deep speech 2, let's just say 5, 5, 5, 12. How many classes? 2. Number of features 10, 24. Doesn't really matter. Yeah, it really doesn't matter. What else do I need? Let's go trainer equals trainer model. I need a loss equals torch.optim.bce. No, wait, and then BCE loss model dot. Do I need to instantiate? What's the weight? Oh no, this is the weight of the loss. And then for the optimizer, we'll put in the model parameters. Torch.optim dot what? I'll just use atom, I guess, and then model dot parameters. And then do I? Model loss optim dataloader. Collate function is pad and transform collate. Save we'll say checkpoints. These save every 10 checkpoints. Device. Well, I do have what? No way. Alright, whatever. I'll do this on CPU and deal with the drivers offline. Num epochs 10, parallel, false, device IDs, whatever. Okay. Trainer dot train. All right, let's debug. Let's get this dummy training going. From oh, it's not from torch import tensor. Okay. How'd that not come? Ah, it's whatever. That's whatever. All right, let's step in. Checking. So now we should have checkpoints. These beginning training. Beginning training epoch 1. And then if we say self.collate function of the self.dataloader, do I have the transforms? I did not specify the transforms. Okay, we'll just say no transforms then. Stack expects tensor to be equal size, but wait, where was it in? How did I get this working last time? I may need to. It's been like maybe a month since I did this. Hold on, data. Yeah, this was the data processing, right? Why did I feed in the data loader? Train audio transforms, train audio transforms. They defined up here, yeah? This is the network. And then in the train loader, it will return everything. So they already did the processing. Train loader. X train data processing. I think that was the wrapper, and then data type, and then so in this case the data is each index, and then train audio transform. So they just threw in the collate function in the, yeah, that makes sense. That makes sense. Collate equals lambda x. Let me see how they did this real quick. Where was I? Let's see, where is it? X, data processing X, train. I see. I'll say pad and transform collate X. And then X should take in now. I guess this should, yeah, this should be the tuple. I mean, let's try this. Maybe the original idea I had was correct the whole time. And then let's go to the trainer. Let's remove this. Example, and then let's just redo this whole thing. Yeah, what's wrong here? Let's see, processed audio shape. Processed audio. Shape. We got 3. What is data? Hold on, let's go through this one by one. Data is a list. Data 0 is a tuple. So an audio label, and then what's the length of data? 32, that's the batch size. Okay, so this is fine. Audio labels in data, if transform is none in this case. We just append processed audio. So now processed audio is 32. Oh, because we're not doing a transformation. I see. Pad. So then, oh, I see. So if we pad and transform, so if, and then once this is done, if transform else processed audio equals torch, and then .utils.rn.pad sequence processed audio batch first is true, unsqueeze 1. This should work. this should work. So this is feature space padding, time domain padding. Cool. Sick, dude. Sick. All right. Oh, so it worked. Okay, so let's see. Processed audio.shape. 32 by, okay. And then final labels is just final labels. Yeah, because we aren't transforming the labels. So we still have, this is, you know, this is under time domain based predictions, like sample wise prediction, which I don't think is even a thing, but okay, cool. So we got that pattern transform, and then if we set up the transformation, and then we could just say transform as such. And then, oh, sick. All right, cool. Very cool. Let's continue. Size of tensor 163, much mass. Let's think about this. Processed audio. Length of processed audio. Alright, processed audio. Processed audio. Let's see, 0.shape. 40 by 163. Must match the size of tensor B, which I assume is 1. Yeah. But I want to pad. What's unsqueeze? Hold on. That shape. Oh, so if we extend it, then that's... No, I don't think we need this though. This should, let's see, eval. Let me think about this. Process audio 1. That's 40 by 122, and then this is 40 by 1, the 163. But if I want to pad sequence, all right, let's look at this. Sorry. If I want to torch pad sequence, can I specify which dimension? 25, 22, 15, and then we have 3 by 300, and the pad according to batch first, batch if true, batch by time by feature. And this is feature by time. Uh-huh. But then I thought that's what the transpose 2 and 3. Okay. So this is assuming that, so it's assuming that this final dimension. So then what I can do is, whoa. Am I in caps lock? Yeah, I am. Audio dot transpose 2, 3. Or sorry, 0 and 1. Oh wait, I can, if it's just a 2D, then I can just say audio transpose. Then do the processed audio and then retranspose. This should work. That should work. But got 3. If I evaluate this, all right. Let's copy this real quick. Let's say a equal, or rather, torch.nn.utils, nn path sequence, processed audio batch first equals true dot shape. 32 by 341 by 40. So then why can't I just transpose 2 and 3? Oh, this should be 1 and 2. Dot shape. Aha. Aha. But then I'll keep the unsqueeze. Unsqueeze 1. I hope this can still work. Evaluate. It does. And then processed audio dot shape. 32 by 1 by 40 by 341. Which means that we are good to go. So, all right, cool. Let's run this back. I do not need trainer.train. What other test label alignment? Why? Is this from before? Yeah, we're good on this. Torch data sets. Okay. Train example and then train.py. Step in. And then the collate. Oh no, we should be good. So let's go trainer. It should work. Should work. All right. Audio labels 0. Do we get an output? No, why not? Layer norm, expected normalized, shape 512, expected input, but got 32 by 32. So then it's just, okay, well, I didn't, okay, that's fine. Yeah, that's cool. That's fine. Because this is just an LFCC based. I'm doing LFCC, but deep speech expects a MEL spectrogram of a specific shape, which I am not abiding by right now. Okay, so the data loader works. Let's get a test for this. Test. Collate. And collate. Wait. Okay, now maybe we're good on this for now. All right. Let's see. So then okay, then I guess we can work on the MEL spectrogram augmentation. Docs, do I need an intro? No. Rename, where's the rename? Overview. We already finished this album. Damn, that was quick. Overview to Sleuth. Let's see, where is the preview? Cool. The overarching goal of this repository is to build out an automatic speech recognition ASR style framework of training defect detection systems. Audio. Because of this, we need to... Is this even an overview? I'll just write for the sake of writing. Because of this, we need to follow certain paradigms for feature extraction and training. I don't know how to tie all this together, so let me just speak about the augmentations. All augmentations are torch.nn.modules classes which serve as light wrappers to torch audio.transform. Is it? Yeah, it should be. Is torch audio transform? Is it transforms or transforms with an additional a label aligner from the Sleuth.augmentations.alignment class. The overarching goal of these augmentations is to ensure that in the time domain we have sample-wise labels. In the time domain, we have sample-wise labels. Show that in the time. While also ensuring that these labels are framed and averaged irrespective of the transformations done on the audio. I'll probably add a figure here. This is really the core that I feel like deserves an explanation. Everything else I think is like really, really trivial. Let me just rename this then. Augmentations. In a nutshell. In short, the handles the framing and averaging of the sample-wise labels generated from the data sets in audio sleuth.data.datasets. I meant to do that. All right. Let me think. The only parameters needed from the for label alignment is win size and hop size. For example, and then let's activate. Import torch from audio sleuth. Yeah, so let's say hop size equals 512, win size equals 256, label line equals label alignment, hop size, win size, label aligner, torch rand n 16 dash shape 626. Where is, no, we're gonna here. Okay, trainer, let's leave these for now. Augmentations, win size, hop size. Import torch, audio sleuth augmentations label alignment. Oh wait, from audio sleuth augmentations import label alignment. Yeah. Hop size equals 512, win size 256. Label aligner equals label alignment, hop size equals hop size, win size equals win size, print label aligner torch dot rand n 16. Oh, I'll instantiate it up here. Audio example equals torch dot rand 16 1 2 3 4. Assume 10 sec at 16 kilohertz. Audio example that shape. I feel like, yeah, this should be good. Okay, so I mean, I like this documentation. I think this is fine. This is a nice start. label alignment also handles padding. Also handles padding. After debugging torch.s, not debugging, but after reading the code of torch.stft, and I'll link this as well because this is a very, very important decision here. STFT. Let's go to source. Actually, maybe let's go to GitHub so I can refer to the link as well. Torch. T. Is it in functional or is it? It's just in torch dot. Where's torch stft? What file is it found in? It's in torch functional. It is in torch functional. Okay. STFT. And then I want to select this line here, which was very important. It was important. This class mimics the code, the padding decision, as we ensure there is no delay in label framing. All right. This is a nice start. Git add docs. About okay, not too bad. Not bad at all. Initial docs, and then so this does work now. I'll need to change this as well. Enable transformation on datasets. So this is done. Enable collate, which I did. Not bad. I do need to add downloaders. So then what I'll do for, where's the examples that I just did? So I have augmentations. I have the half-truth, and then from torch.utils.data import data loader, and then from audio sleuth.data. Oh no, I put it in augmentations, didn't I? Or sorry, I put it in datasets. Okay. Pad and transform. You can feed this data loader into your training. Batch size equal. Create chains of transformations. All right, all right. Get add readme. Get update readme. Status get def audio sleuth data. What did I change here? Def. Oh, yes, yes, yes. I most definitely need to change this. Get add audio sleuth data collate. Add working pad and transform collate. Git push. And then what I change here? Is this just, this might just be a static get diff audio sleuth trainer. Yeah, it's entirely static. Okay, then I'll just check it out. Yeah, I don't think this is very much a static. Yeah, yeah. All right. Damn, not bad, bro. So I'll probably work on downloaders then. Spec augmentations, and then evaluate in the training. So then, yeah, on Friday, I'll probably build out the downloaders, and then maybe flesh out the documentation just a bit more. Maybe talk about the approved augmentations, and then how to build your own augmentations. This will be nice. I'll probably add the approved after I'm done with the spectrogram and the mel spectrogram, and then I'll kind of write a brief summary on how to build your own augmentation, and then we can call it a day on that. This is shaping up quite nicely. I am very happy with how this is going. Let me get examples. I'll rename this train deep speech to example. Or I'll just call this train deep speech 2. And then, so yes, to do enable downloader or create downloader. This is shaping up really nicely. I'm really happy with this, how this is going. So let's keep it going. All right. Thank you everyone for tuning in. I will see you guys on Friday, same time as usual. Thank you for tuning in, and enjoy the rest of your day. Peace.